Okay, so if you're a developer, you definitely know this feeling. You're deep in a project and you hit a problem that feels, well, just strangely familiar. It's that nagging feeling in the back of your head that says, wait a minute, I've solved this exact problem before.
Right? Whether it's figuring out the best way to create a new object or trying to get two totally different parts of your system to talk to each other, these challenges just pop up again and again. And look, reinventing the wheel every single time is not just exhausting, it's really inefficient. So, what's the smarter way to build software?
Well, that's where design patterns come into the picture. Now, don't think of them as specific code you just copy and paste. They're more like a high-level description of a solution. These are proven, reusable approaches that have been tested and refined by tons of developers over many, many years. The best analogy? Think of them like an architect's blueprint for a house. The blueprint doesn't tell you what color to paint the living room, right? But it gives you a solid, reliable structure to build on. Design patterns do the exact same thing for your software. They give you a framework that leads to code that's way more robust, scalable, and easier to maintain.
Now, I know what you're thinking. There are dozens of these patterns, and that can feel pretty overwhelming. But here's the good news. They can all be neatly organized into 3 fundamental groups. Understanding these categories is really the key to knowing when and where to use a specific pattern.
First, we have creational patterns. These are basically your how-to-build guides for objects. Then you've got structural patterns, which are like the instruction manual for assembling those pieces into larger, flexible structures. And finally, we have behavioral patterns. Think of these as the rule book for how all these different parts talk to each other and get work done. So let's break each one down.
First up, creational patterns. As the name kind of gives away, these patterns are all about the process of creating objects. They give you ways to create objects while hiding the nitty-gritty creation logic, instead of just calling the new operator all over your code. So why is that such a big deal? Well, these patterns give you control over the creation process. It means your code becomes way more flexible, it isn't hard-coded to specific classes, and that is just fantastic for future-proofing your application.
To make this really stick, let's look at one of the most useful creational patterns out there, the builder. It is a fantastic solution for a headache you've probably had before.
So picture this. You're building an object that has a whole bunch of different configuration options. Let's say it's a house object. Some houses have a swimming pool, others have a 2-car garage, and some have neither. If you try to handle all those combinations with a constructor, you end up with this tangled, mile-long mess of parameters, and a lot of them might be null. It's confusing and honestly, super error-prone.
The builder pattern just cuts right through that mess. It separates the construction of a complex object from its final version. What you get is a helper, a builder object, that lets you add the different pieces one by one. And when you're done, you just call a final build method to get the finished product. Here's how it works in practice. You start with a base builder. Then, you just chain the methods for what you need. Add walls, add windows. Want a pool? Cool, add it on. Don't need a garage? No problem. Just skip that method call. Finally, you hit .build, and out pops your perfectly customized house object. It's clean, it's readable, and it's incredibly flexible.
Okay, so we know how to create objects flexibly. Now let's move on to our second category and see how we can assemble them into bigger structures. Welcome to the world of structural patterns.
Structural patterns are all about relationships. They help you organize your classes and objects, and this is the crucial part. They do it in a way that ensures if one little part changes, your entire system doesn't have to change along with it.
So here's a classic problem that structural patterns are great at solving. You have 2 classes, and their interfaces just don't match up. One system expects data in one format, and the other provides it in a completely different one. It's like trying to fit a square peg in a round hole. How do you get them to work together without rewriting one of them from scratch?
You use an adapter. It's just like that travel adapter you throw in your suitcase for your electronics. The adapter design pattern acts as a middleman. It wraps one of the objects and gives it an interface that the other object can understand, basically translating calls from one to the other.
This pattern is perfect for something like a real-world business change. Imagine your food delivery app is built to handle food item objects, but now your company wants to start delivering groceries. A grocery item has totally different properties, like weight instead of restaurant name. So what do? Rewrite your whole system? No way. You just create a grocery item adapter. It takes a grocery item, makes it look and act just like a food item, and your existing system can handle it seamlessly. No big rewrite needed.
All right, we've covered creating objects and assembling them. The final piece of the puzzle is how these objects actually talk to each other and figure out who does what. Welcome to the world of behavioral patterns. You see, these patterns are all about the dynamics of interaction. They don't just describe the structure, but the patterns of messages and communication between your objects to get something done. This is what really helps make your systems more flexible and loosely coupled. Think about a navigation app for a second. The user can ask for a route for driving, for walking, for cycling. A really naive way to code this would be to use a massive if-else or a switch statement in your route calculation method. But you know that's going to become an absolute nightmare to maintain. What happens when you want to add a new mode of transport, like a scooter? You have to dig into that giant block of code and risk breaking everything.
The strategy pattern offers a much cleaner solution. It tells you to take each of those algorithms, each strategy, and wrap it up in its own class. Now your main object just holds a reference to whatever the current strategy is and tells it to do the work. The strategies become totally swappable.
Look at how this works with a simple calculator. The calculator itself is our context. It can be given an add strategy or a subtract strategy, and so on. The key thing here is the calculator itself doesn't actually know how to add or subtract. It just knows to call the execute method on whatever strategy it's currently holding. So if you want to add division later, you don't touch the calculator code at all. You just create a brand new strategy class.
So, we've covered the three main categories of design patterns, and we've looked at a key example from each. But let's bring it all home. Why should you actually invest the time to learn and use these concepts in your day-to-day work?
Honestly, the benefits are huge. You'll write more robust, more scalable code, period. You'll have a shared vocabulary that makes working with your team so much easier. If you say you're using an adapter, everyone immediately knows what you mean. And let's be practical. A solid understanding of these patterns is a massive advantage in technical interviews. So the real takeaway here is to start thinking in patterns. The next time you hit a tricky coding challenge, just pause for a second and ask yourself, is this a problem that someone else has already solved? Because chances are the answer is yes, and there's a blueprint that's been waiting for you all along, ready to make your code more elegant, more efficient, and way more powerful.